Space looks calm from a distance, a silent ocean of stars. But just above our planet, hidden within the glow of auroras, lies a deadly trap. Two invisible rings of radiation, swirling and pulsing with energy from the sun. They are called the Van belts, and every spacecraft that leaves Earth to deep space must sail right through them. These belts are the reason your GPS works, why satellites need armor, and why sending humans beyond Earth was once considered impossible. So, how do our fragile machines made of circuits, metals, survive this invisible storm? It all started by accident in 1958 when the US launched its first satellite, Explorer 1. The goal was simple: measure cosmic rays in space. But when the data came back, something was strange. The sensor maxed out constantly. They weren't broken, they were being overwhelmed. Dr. James Van Allen realized what happened. Earth's magnetic field was trapping high-energy particles, a radiation storm circling the planet. Humanity had just discovered its first invisible monster in space. The Van Allen belts are made of two main layers: the inner belt, packed with protons moving at nearly light speed, and the outer belt, a cloud of electrons from the solar wind bouncing back and forth along magnetic field lines. A single particle in those belts can tear through spacecraft material, flip the bits in computers, and slowly poison electronics with radiation. For humans, it's worse. Without protection, the radiation dose could be fatal in just a few hours. Yet, in 1969, we decided to go anyway. When NASA planned the Apollo mission, the Van Allen belts were one of their greatest fears. Could humans survive the journey to the moon? The solution wasn't armor, it was speed and precision. The Apollo spacecraft crossed the belts in just about an hour, flying through their thinnest regions. The aluminum hull offered just enough shielding to keep the astronauts safe. Their total radiation exposure was less than a medical X-ray. That precise dance through the danger zone was a triumph of human ingenuity, and the reason Neil Armstrong lived to take that giant leap. But Apollo was just the beginning. Since then, thousands of satellites, spacecraft, telescopes have crossed the belts again and again. Some, like Hubble, orbit just below them, staying safe in calmer space. Others, like GPS satellites, live right inside the outer belt, enduring constant bombardments. So engineers began a new kind of arms race, not against nations, but against radiation itself. They developed radiation-hardened electronics, special chips that resist cosmic damage. They designed a redundant system, so if one computer flips a bit, another corrects it instantly. And they wrapped vital instruments in metal, polyethylene, and sometimes even gold foils. But if Earth's belts are dangerous, Jupiter's are real monsters. Its magnetic field is 20,000 times stronger than Earth's, trapping radiation so intense that an unshielded spacecraft would die in hours. In 1999, Galileo became the first probe to orbit Jupiter. Over time, radiation crippled its instruments, scrambled data, and scared its memory. Engineers were in awe. Their creation was being eaten alive by the planet's magnetosphere. Yet from Galileo's sacrifice came knowledge. When NASA designed Juno, it built a spacecraft unlike any before. Its heart protected by a titanium vault, 1 centimeter thick, shielding its brain from Jupiter's fury. Against odds, Juno still sends data home today, a survivor among the storms. Today, as we build smaller and smaller spacecraft, from CubeSats to Mars explorers, we face a new paradox. Smaller electronics means less protection. So scientists are experimenting with new ideas: magnetic shielding fields, self-healing circuits, and AI that can help recognize when radiation strikes and repair itself. The next frontier isn't just exploring space, it's learning to survive it. Above our heads, the Van Allen belts still rage, an invisible storm, guarding our planets forever. Every spacecraft that passes through them carries a piece of human courage, wrapped in metal and mathematics. In a universe full of danger, it's not our shields that define us. It's our determination to face the storm and keep going. Don't miss out. New videos drop every Sunday evening. Hit subscribe and ring the bell so you are the first to watch.